So today's lesson is all about naming angle pairs formed by transversals. Well, we can't possibly do this until we understand what in the world the transversal is. Okay? That prefix trans, you hear it all the time. If you take a transcontinental railroad trip, you're going across the continent, right? If you take a transatlantic flight, that goes across the Atlantic Ocean. So when we are talking about transversals in geometry, they are simply, a transversal is just going to be a line that crosses over two or more other lines. Okay, so I'm literally looking at a line that crosses over other ones. That's not so bad. Okay, so let me draw you a picture of what it could look like. Notice I didn't say that the other two lines had to be parallel, had to be intersecting, whatever. It actually doesn't matter what they are. So here's just two random lines. And then if I cross over them like this, what I have just created there with that red line is a transversal. Okay, so I'm just going to label my three lines. So here's line A, line B, and line C. So hopefully you can clearly see that line A is my transversal in this case. That's the line that's crossing over the other ones. Okay, could you have more than one transversal? You can. Some diagrams have lots of transversals, but what's nice is that we actually only ever care about one of them at a time. All right, so we'll see more complicated diagrams that have lots of lines crossing over other lines. So how are you supposed to know which one to pick? Don't you worry, I'm going to walk you right through it. Okay, but in this picture, there's only one transversal and it is line A. So I'll go ahead and say that line A is the transversal. Okay, I'm going to draw you another image of what a transversal could look like. A lot of times, I know me in particular, when I draw them, I almost always draw this same exact diagram, but they don't have to look like that. Maybe my other two lines look something like this. There's two lines, right? And then if I just draw a transversal that crosses over them, maybe it looks like this. That still counts, right? I still have this red line that's crossing over the other two. So if I just label my lines here, A, B, and C, this time C is my transversal. Okay, C is the transversal. All right, so when you have a transversal, you get like this bonus gift because not only do you have this cool new vocab word transversal, but it has delivered to you a whole bunch of new angles. Do you see them all? Let's just take a look at this one. Look at all these new angles that cropped up just because I drew in that transversal. Same thing happens over here. When you draw that transversal, look at all these angles that are now there that weren't there before. My goodness. So you're going to get a whole bunch of new angles that appear. And what is so interesting and what we're going to be looking at in this chapter is how, if I pick two of those angles that are created, how are they related to each other? We're going to find out that sometimes the angles are going to be equal to each other. Sometimes they're going to be supplementary. Sometimes they have absolutely nothing to do with each other. So it's all going to depend on the situation and what's happening. But you'll always get new angles that pop up. Okay, so I just want to put that down in words. So I'm going to write here, when a transversal crosses over other lines. Oops, sorry, I'm a little bit off. When a transversal crosses over other lines, new angles are formed pairs of those angles. Oops. Okay, so when you take pairs of these new angles that are formed, there are 6 different names that we could use to describe those angle relationships. Okay, so what I'm going to do in just a minute is I'm going to list all 6 of those. We only know right now what one of them is. The other 5 are going to be new to us today. We haven't talked about the other 5. We know one of them. Okay, so let me give you a second to just get caught up. So today, all of our angle relationships are going to be one of these 6 things. Okay, the first one is the one that we know, which are vertical angles. We've already talked at great length about those. You guys know what they are, I'm hoping. Don't forget, that's when you have an X and they literally are staring right at each other. So vertical angles, remember, have to have the same vertex, and they need to be literally right across from each other like that. Okay? The next one, this you saw it on the homework, but we didn't know what it was, right? So I told you at the time, hey, that's not the right answer if you see it. The word was corresponding. I'm going to describe what those are on the next page in just a minute. I just want to make the complete list of all the 6 possibilities. So I'll even say here, described on next page. If you're looking back in your notes and you're like, I don't know what a corresponding angle is. Now you'll know. Oh, look to the next page and I'll tell you all about it. Okay, and then the next 4 are also new to us. And you're going to see a little pattern forming here. So they are same side interiors, which that's a lot to write, right? You could abbreviate this as SSI. The next type is something called same side exteriors, or SSE. The next one, check this out. This is now going to be alternate interior, or AI, and I bet you could figure out what the last one is if you sort of, oh, did my camera freeze? Looks like it. Sorry, let me just refresh this. There we go. All right, so here are, we have 1 left to go. Have you figured out what it is based on the pattern that you see with the 3 above it? It's got to be. Anybody have it? The only one we have left is alternate exterior, or AE. So hopefully for these last 4, do you see what's happening here? You have one word here that's either going to be same side or alternate. And then your second word is either going to be interior or exterior. So what even are these? How are you supposed to put this together? That's what we're going to use that flow chart for that I gave you. So I'm going to mark over here that the flow chart helps me figure out which of those 4 I have. So I'll just say use flow chart. Okay, well, this flow chart actually will help me determine which of these 6 it is, but I have to know what vertical and corresponding angles are to be able to really kind of work my way through the flow chart. So speaking of which, what are corresponding? We said that we would describe that on the next page. So let's make good on our word here. So I do need to flip this over. So let me just give you a second to grab any last bits that you might need. So now let's flip and talk about what corresponding even is. Okay. To do this, I'm actually going to draw myself one of my diagrams. So give yourself 2 lines and then go ahead and cut it by a transversal. I'll call my lines X, Y, and Z. All right, so if you are drawing the same diagram as me, I hope you are, make sure that you number the angles the same way that I do, because we're going to reference the number angles, and if you number yours differently than me, then it's not going to make any sense. Okay, so I'm just going to come in here and I'm going to call this angle 1, angle 2, 3, and 4. And then I come down to my next set, and then I have 5, 6, 7, 8. Like we're in dance class, right? So there, in this picture, I got 8 angles because of that one transversal. Thanks, transversal. Look at all those happy angles. All right, so now let's talk about what corresponding even is. This is going to sound a little weird, but I think once you sort of visualize this, it becomes really, it makes sense to sort of talk about it this way. Each little, see how there's 2 kind of groups of angles? I have these 1 through 4 up here, and then 5 through 8 down here. I literally want you to think about them as people sitting at a dinner table. So if you imagine, I'm even going to draw around dinner tables. So let's say they're at a restaurant, they're all sitting there. They're all sitting there. The people that, or the angles that are corresponding are going to be the angles that are sitting in the same exact seat. They're just at different tables. So for example, if you take a close look at angle 1 and angle 5, aren't they really sitting in the exact same spot? They're just at different tables, that's all. They're both in the top left of their little group. 1's in the top left, 5's in the top left. So that's an easy way to kind of remember what corresponding angles are. They're the angles that match up with each other, right? They correspond to each other. They match up. So I'm just looking for which angles are in the same spot, just in a different location. Okay, so angles that are in the same spot but different location. I'll even add, if you like it, same seat, different table. Another way to think about this exact same thing. Same seat, different table. So I gave you one example. It was angle 1 and angle 5. Would anybody care to give me another corresponding angle pair? Who else?
2 and 6.
Yes, 2 and 6. They're both in the top right of their little group, right? Top right, top right. angle 2, and angle 6. Someone give me another one. Yes, 4 and 8. And we might as well give the last one too. What's the last one? Last one?
3, 7.
Yes, thank you. 3 and 7. So there's all of my corresponding angle pairs that are in this particular diagram. Same seat, different table. Okay, so that's what we're talking about when we are mentioning corresponding angles. All right, so now if we think back to our list of 6, we know vertical angles. We had a whole day that was on just vertical angles in the last couple weeks. Now we know what corresponding angles are. Okay, same seat, different table. And now all we need to do is figure out those last 4. Those are the ones that are kind of weird, but it's not weird if you follow the steps. Okay, so let's just jump in and do one. And I'm going to show you sort of how to work your way through the flow chart and how to answer all the questions that are asked. So let's do this one right here. So I'm going to have us focus on this question right here. Yes, it's labeled number 6. That's fine. All right, hold on. I want to get it all lined up right here. Oh boy, okay. So if I'm going to do this, I'm going to grab my flow chart. And you'll notice, hopefully you have a copy either digitally or right in front of you. So here's kind of what it looks like. So I just give you an example at the top. And then it says start here, and you're just going to work your way down the boxes. Okay, so the very first question asked me, are the 2 angles vertical angles? So let's look at the one that, the example that we're doing. These 2 right here. Let me zoom back in. Are those 2 angles marked X and Y? Are they vertical angles? What do you guys think? Someone just shout it out. Vertical, yes or no? I don't hear any shouting. Are they vertical, yes or no?
No.
No, they are not. So just remember, vertical literally have to be same vertex. They're looking right at each other like those 2. Okay, that's vertical. So the ones that we're looking at in this example, they are not, right? They don't have the same vertex. X's vertex is over here, Y's is over here. So correct, not vertical. So if I look at my flow chart, I'm going to follow the no arrow, right? If the answer was yes, I'd be done. I would know that they're vertical and I get to move on. I'm just trying to figure out which of the 6 it is. All I've done so far is eliminate vertical. I know that that's not the right answer. Okay, the next question says, determine which line is the transversal. So here's how I like to figure out. I mean, obviously in this diagram, it's very easy which one line is crossing over the other 2. I'll give you that. But sometimes the diagrams are really kind of, sometimes you have lots of transversals. How are you supposed to know which one is the one that matters? Here's how I think about transversals. You want to think about it like a train. If this was if this was the route that train A takes, here's the route that train B takes, and here's the route that train C takes. Which one, if I'm trying to travel between my angles, what train do I have to take? I've got to take C. That's the only one that connects the 2 angles. C is my train. If I'm at X and I'm trying to get to Y, I'm taking train C. If I took train A, I'm never going to get over to angle Y. I'm never going to get there. Same thing. If I took train B, I'm never going to get to angle X. There will only be one transversal that connects 2 angles. That's it. You can't have more than one transversal connecting two angles. It just doesn't exist. So there will only ever be one transversal. And in this case, it's line C. Okay, and again, I know it's obvious in this diagram, but we'll have plenty of diagrams where it's not obvious. So it is kind of important to sort of break it down in chunks right now. All right, so C is my transversal. Okay, got that. The next question says, are the two angles corresponding? We just talked about what corresponding angles are. They have to be in the same seat, different tables. Do I have that scenario here with these angles X and Y? Are they in the same seat, just different tables? What do you guys think? Yes or no? Are these corresponding? If it helps you to literally draw the dinner tables, go ahead. No, they are not in the same seat, different tables. Right? It's a little bit easier to see if you actually draw the tables. Here's X sort of in the top right. The top right is over here, and that's not where Y is. So they are not corresponding, correct? Okay, so next question, if I'm following along my flow chart, no, they're not corresponding. So now it says, determine if the angles are on the same side of the transversal or alternate sides. So remember, line C was my transversal. Okay, so if my angles are both, say, to the left of the transversal, or both to the right of the transversal, or in this case, if they're both above the transversal, or both below the transversal, then I'm going to pick same side, right? Because they would both literally be on the same side of the tracks, if you will. They're on the same side. If they alternate, if one's above, one's below, one's to the left, one's to the right, then I'm going to pick alternate. So what do I have in this example? Do I have both angles on the same side of line C or alternate sides? Just call out. Alternate is correct. Yes, see that? One's above, one's below. I have one up here, one down here. That's my first word. The first word is going to be alternate. Okay, there's my first word. Now I just have to figure out what the second word is. Okay, so if you look at the chart thingy here, my flow chart. So when you get to this question, it's going to ask you same side or alternate. We figured out it's alternate, so I'm going to follow this box over here. So I'm just going to read this to you. I'm going to zoom out a little bit. Nope, that's the wrong way. Woo! Okay, so I'm just going to read this to you in case you don't happen to have it in front of you. And then we'll see how this kind of works. All right, it says, there's two other lines besides the transversal that make up the two angles you're looking at. If you have a complicated diagram, ignore all of the other lines besides these two. Now, ask yourself if the angles are both on the interior or in between those two lines or on the exterior or outside of those two lines. Okay, let me show you what I mean. So I'm going to come over here. My diagram's not very complicated. I only have 3 lines, so I kind of can't mess this up. Well, I guess you could, but there's only 3 lines. I already know that C is my transversal, so the other 2 lines that matter are A and B. So everything in between A and B is going to be the interior. Everything outside of those lines, so if I had an angle out here or an angle out here, that's going to be the exterior. So in my case, clearly we can see the angles X and Y are both in between the 2 lines, so they are in the interior. Does everybody see that? And that's my second word. So once I figure that out, now I know, okay, it's just alternate interior. And I've got it. Okay. Was that so bad? It's not so bad. It'll get better and faster as we practice more of them. Okay, you ready? Let's try. I don't want. Okay, let's try this one. I'll just move right to this one. Okay. So I'm going to work my way through and I'm going to ask you guys for help. So be ready to unmute yourself or call out if I call on you. All right. So I have a new problem. I'm going to start at the top. The very first question is, are my two angles vertical? They're not here, so they can't answer me, but Riley can. Riley, the two angles in this picture, are they vertical angles? Yes or no?
No.
Correct. They are not. All right. So then we move on to the next box. The next box asks me to determine who the transversal is. So you'll notice that they don't have the lines labeled with letters. If they're not, you can always just add them in. A, B, C, D, if you want them. Okay. Especially it helps when we're talking about them out loud. If you were just doing your homework, you probably wouldn't have to label them, but we need to, because we need to identify them verbally. Okay, so anyway, who is my transversal? If I'm trying to take a train from angle X to angle Y, what train are you taking? Matt?
C.
Yes, C is the one and only line that connects my two angles. Does everybody see that? Right? If you try D, D kind of starts at Y, but it never gets over to X. So D is actually useless, right? It has nothing to do with, that's not my transversal. A is not, it doesn't connect the two. B doesn't connect the two. I need to connect both my angles, and the only one that does that is C. So great. Now I know that C is my transversal. Perfect. The next question, Molly S. Are these two angles corresponding?
Says no.
Correct. Remember, corresponding is same seat, different table. So if you want to draw the dinner tables, you can see angle Y is in the bottom left, but angle X is in the top left. They are not sitting at the same seat. So you are correct in saying that they are not corresponding. So now, next up, we're going to determine if they are same side or alternate. So Katrin, we already said that C is the transversal. Are my angles on the same side or alternate sides?
Same side.
Same side. Does everybody agree? See how they're both to the left of line C? They're both to the left, so they're on the same side. That's my first word, same side. Now I just got to figure out if they're interior or exterior. Okay? And this is where sometimes confusion can sort of set in, because there's extra lines in this diagram. What two lines am I talking about, them being on the interior or exterior? I don't know. You do know if you follow this rule, okay? C was the transversal, so it's obviously important. What other two lines make up the angles? B is part of angle X, so I need that one. A is part of angle Y, so I need that one. Do I care about line D? No, not at all. I'm only ever going to care about three lines at a time. The transversal and then the other two lines that literally make up my angle. Every other line doesn't matter. So no matter how complicated the diagrams get, you only care about three lines. All the other ones are irrelevant. See you later, other lines, because I don't care about you. I do care about my best friends, line A and B in this case. So now my last question is, are my two angles on the interior of those two lines or the exterior of those two lines? Hannah is not here, so she can't answer me, but Nick, you came, didn't you? Yes, Nick, tell me, are they on the interior or exterior?
Interior.
Yes, interior. They are in between the two other lines, so same side, interior is my answer. Yes. Okay. All right. I'm going to switch it up on you. You ready? This one. I'm going to zoom in a smidge. Whew. So let me ask you the first question. Molly B, are these angles vertical angles?
She says yes.
She is correct. And guess what? That means you're done. You don't have to go down the rest of the flow chart. Once you know which of the 6 it is, you're finished. I can't tell you how many times kids say vertical and then they like keep going. I'm like, what are you looking for? You have the answer. That's it. Move on. You're done. Isn't that nice? I love when vertical angles pop up because they're so fast. How about let's try this one. So I'm going to ask you the same question. Let's see. Demetrius, are these 2 angles vertical angles?
Yes.
Ooh, be careful. They are not. Vertical angles have to share the same vertex, right? Vertical, they literally have to like these 2 would be staring right at each other. So these are not going to be vertical. However, are they corresponding? Kaya, tell me if these are corresponding.
Yes.
Yes. Look at that. Same seat, different table. If you draw on the tables, if you want to. Look, bottom right, bottom right. Yes, corresponding. And again, you are done. You don't have to do anything else. Once you figure out they're corresponding, you have your answer. That's one of the 6 choices. Move on. Okay, I'm going to try and give you, let's see, I'm going to try and give you a tricky one. Let's do, yes, I think that one can be tricky. Let's try this one. This one's got some extra lines in it that we don't need. But let's walk our way through this one together, okay? So first question is, Steve, are these 2 vertical angles?
No.
Correct. They are not vertical, so that's out. I need to label all these lines. A, B, C, and D. Okay, so now I want to figure out who's the transversal. Sophia, which of these lines, A, B, C, or D, which is the transversal?
D.
Correct. That would be the one train route that connects my 2 angles X and Y. That's the only one. I know you might feel like C does, but look, it never gets to angle X, so that can't be right. So it's got to be D. Okay, so I'll just underline it so we remember. That's my transversal. Okay, next question. Mary, are these 2 corresponding? So that's, remember, same seat, different table. Are X and Y corresponding, yes or no?
No.
Correct, they are not. So now I have to move on. Remember that D was my transversal. So I need to ask myself if my angles are on the same side or alternate sides. John, what do you say? Are they on the same side of line D or alternate? I want to know if my angles X and Y are on the same side of line D or alternate. Yes, one's on the left, one's on the right. So that's my first word is alternate. And now I just need my second word. Is either going to be interior or exterior, right? So, Olivia, what do you say? Is the last word interior or exterior?
She says interior.
Okay, so let's rewind. There's only 3 lines that I care about. obviously we have the transversal that we already talked about. So let me highlight that one in red. Okay, that one matters. And then the other two that matter are the ones that make up my angles. So line A makes up angle Y, and line B makes up angle X.
Oh.
Did you want to change your answer?
Yeah, it's exterior.
Yeah. So the three that I have highlighted here in red are the ones that I care about. Line C, you guys, you could literally delete line C and it's not going to change anything about angles X and Y. So just ignore that it's even there. Okay. Now, if you're looking at this, I know that this region here is the interior. That's in between the two lines. And then my angles, I know I sort of drew over them with marker, but they're both on the outside, right? They're both on the exterior. So that is my second word, exterior. Yes. Okay. I'm going to give you guys one, and I'm not going to walk you through it. I want you to decide what it is. Let's try this one. That one's a good one. Okay. So walk yourself through it. See if you can determine which of the 6 relationships these two are. Feel free to send me your answer when you have it. Oh, I got one. And it's right. Keep those answers coming, people. Send them, send them. Let me see what you're thinking. You could even abbreviate if you want. You can use AI, AE, SSI, SSE, COR for corresponding, V for vertical. Oh, I got another correct answer. Keep them coming. Give you another few seconds. Okay, so those of you that answered same side interior, you are correct. Same side interior. So let's just go through real quick how we arrived at that answer. Are they vertical? No. Vertical literally have to have the same vertex. They're staring right at each other, okay? If they're at the dinner table, they're literally staring at each other, okay? They have to be at the same dinner table. Vertical angles require that. I don't have that here, so that's out. Corresponding has to be at the same seat, different tables. So if you take a look, Y is in the bottom left, X is in the top left of its little group, right? If I draw the tables in, you can see that they are not actually at the same seat. They're in different seats. Okay, so we're not going to go with corresponding. So now I got to follow my transversals. So let me just label it. Oh, I did? I'm sorry.
Video locked. Video room, the radio store. Yeah. That's your generation, girl.
I remember.
I'm sorry, I don't remember.
You don't remember? I think I do. I remember the video on MTV like a million years ago. I remember, yeah. I might have only just been born, but I remember. I can't believe The Birdcage. Do you remember that movie? That was such a great movie. The Birdcage with Robin Williams. You know, it was released 25 years ago. I couldn't believe it.
Oh my goodness.
Yeah, that's nuts to me. Oh, anyway, so this one, where were we? We were talking about who's the transversal. The transversal in this case is D, right? That's the one that's connecting the two angles that I'm talking about. So D is my transversal. Got it. Now, the other two lines that matter. Do you see how I could literally just erase line C and nothing changes with my two angles? Nothing changes. I still have X. I still have Y. There, I get rid of C. I don't even need to look at it anymore. And now it's hopefully easy for you to tell that A and B are the two lines that I'm talking about. So all this here would be the interior, which my two angles are. They're both on the interior. So put it all together, same side interior, SSI. Okay, I'm going to try and trick you with this last example. It looks so simple, but I bet you anything I'm going to get a few people tripped up on this one. So you take a minute, see if you can figure out what you think this is. Send me your answer if you know. Riley, that's correct, yes.
Cute Riley.
Okay, so I wonder if any of you are kind of stuck on this one because you're like, all right, well, they're both on the same side of the transversal, but then one's on the inside and one's on the outside. So do I pick interior or exterior? Well, this is not my first rodeo. I knew that some of you would get stuck in that trap, and that's why I included it right on your flow chart. So if you look down here towards the bottom, there is an option for one is interior, one is exterior. What does that mean? Here's what it means. It means basically that you probably made a mistake. You didn't follow the flow chart in order, so you missed that they were vertical or corresponding. It is possible tomorrow we'll have ones that literally don't have a relationship with each other. But today, everybody has one of the 6 relationships that we're talking about. So if you got here, you forgot to ask yourself about vertical and corresponding. Because this example, they are corresponding. Or maybe you asked yourself, but you answered incorrectly. They're corresponding. They are both in the bottom right of their little group. If you draw the tables, you can definitely see that they are both seated in the exact same spot, just at different tables. Okay, so corresponding is the winner. So if you do follow the flow chart and you ask yourself the questions in that order, I save you from going through alternate, same side, interior, exterior, if it's vertical or corresponding. Because once you figure out it's one of those, then you're done. You don't always have to go through everything. Okay, so vertical and corresponding, I actually really like them because it's so much faster. It's just one thing. Oh, I got it. I get to move on. All right, so as I said, tomorrow we are going to just keep practicing. I'm going to throw in a few sort of trickier situations, and we'll really solidify this tomorrow. Now, tonight, your homework is basically exactly like I've just been doing here. So it's going to be on CUDA, not on Delta. So give me 1 second here. I'm going to stop